This paper, the Amazon Dynamo presented in this paper from 2007, is a distributed database key value store. The paper talks a lot about the business requirements that inspired Dynamo, but I'm going to skip that part. And instead, we're going to be talking about some of the interesting trade-offs that it makes, how you might strategize between consistency, availability, cost-effectiveness, and performance. And notably, this paper concentrates on how you can apply application-specific logic to resolve inconsistent states in the database. And they call this technique eventual consistency. As a side note, this paper inspired Apache Cassandra. Apache Cassandra followed the architecture from Amazon Dynamo described in this paper. Now there's actually something at Amazon called DynamoDB, which was, in fact, another iteration on this idea. So it's inspired by Apache Cassandra in some ways. At least that's what the Cassandra people will tell you. So what goes around comes around. So the great problem of distributed databases is the multi-master problem. When you have a single database master making an ordered series of atomic commits, the state of the database can be fairly easily ascertained, and you can keep it consistent. But when you apply the same write to two different machines, the race condition emerges. Say that you write the key foo to machine A, and then a couple milliseconds later to machine B. In between those two writes, you'll get a different answer depending on which machine you ask. So the straightforward solution to that, the conservative solution, is to have one machine serve as a master for a given write and have it fan out to all the other nodes, fan out the write to all the other nodes, and have them, and to wait until it's heard back, confirming that the write was successful to all the other nodes before it declares the write valid and moves the state of the distributed database forward. The classic problem with this very conservative technique is that the speed at which the write becomes available, that's bolted to the speed of the slowest node. So, and what happens if that node is in fact beyond slow, but in fact offline due to a network partition or a hardware failure? Well, there's various ways to optimize this. For example, you can apply consensus algorithms like Raft and Paxos, which allow you to hear back from only a subset of nodes before you declare that the database is moved forward. You can also start partitioning the database. You wind up with, say, recent writes going to a hot node. What all of these techniques have in common is that they're trying to approximate what looks like a single unified state machine from the outside. You can't tell what's inside the black box, but it's still going to be, it's going to have the appearance from the outside of being this thing that looks like it's got a series of atomic commits. So the Amazon folks thought about this in a different way. They asked an interesting question with regards to inconsistency. So what? Do we really care if the database is inconsistent? And, well, sometimes, yeah. If you're managing money, then you don't want to have a double spend to occur where the same funds are withdrawn from two different nodes before those things are reconciled. But let's consider another case, which is the Amazon shopping cart. Say that, well, somebody's browsing the Amazon website, that the user selects one item, and that goes to one node, and then they write to a different master when they put a second item in the shopping cart, and that gets written to a different node. So then later you're trying to tell them what's in the shopping cart, and you make that query, and it goes and it talks to two different nodes, it gets two different answers. So, well, what do you do about that? You could possibly choose one, or maybe you could say that delete both of them. Both of them are wrong, so now there's nothing in the shopping cart. Maybe you could ask the user, it seems like we've got this inconsistency, what's right? But how about you just put both of the items that are in there, you merge both of them into the shopping cart. How often is that going to be right? It's going to be right almost all the time. Maybe once in a blue moon that's going to be wrong, but in general, you want to put both of those things into the shopping cart, and then you get both the sales. And so the odds that the customer is going to be, or the user is going to be exposed to this problem to begin with are fairly small. And so long as the eventual consistency arrives before checkout, it's all good. So let's consider now another application, which is the session state. And session state can mean a lot of things, but let's say for the purposes of discussion that it's keeping track of your browsing history on the Amazon website. So then you can you've got two different masters that have two different histories. Well, you can just decide that the way to resolve this particular discrepancy is to say that the last one, assuming they're timestamped, the more recent one wins. And how often is that going to be right? It's going to be right almost all the time. And then finally, there's a case that I collaborated on that I mentioned when we were just getting set up here, that at the previous place I used to work, it was Eventful. And we did, we were an event listing website. And the thing is that the event listings would join, they'd be far into the future, and you could buy tickets through us, but it wasn't, we would actually shell out to it, or we would send you to a third party. So it wasn't actually that crucial that we be absolutely right all of the time. Now, we send you to Ticketmaster, they have to be right all the time because they don't want to sell you a ticket that's going to the wrong place. But if we were wrong every once in a while, so long as we were right almost all the time, it didn't matter that much. So in fact, this is another application for an eventually consistent database, is just to be right almost all the time, and that's good enough. And then we got to reap the performance benefits of having this cluster that didn't have to be right all the time. So in conclusion, the thing that I found the most interesting about this paper was how it discarded a requirement that was often assumed to be absolute and inviolable. And the application of such bold and novel thinking is something that I think we can all aspire to apply with eventual consistency. Thank you. Any questions that will come up? I think that we'll have one eventually. Mike.